In this video, I will tell you what is a rectifier. Now, rectifier is one of the application of a PN junction diode, and this is a PN junction diode. We have a P and we have an N. Under forward bias, this can be represented as P connected with positive terminal of the battery and N connected with negative terminal of the battery. Now, the same PN junction diode, when it is reverse biased, P is connected to negative and N is connected to positive. Anyway, this is not a rectifier. A rectifier is a device, is a PN junction itself, and its purpose is to convert AC into DC. Now, this is an AC current, right? From powerhouses, even the input to our house, in our house we are receiving AC current. Now, see, from powerhouse we have AC generated. So this at AC generator we will get AC current, and these AC current are sent to the transformers or near to the place where it is distributed as high voltage, that is 11 kV distribution line. So in this distribution line, current with the frequency of 50 Hz is sent at high voltage, and we have learned why we are sending at high voltage. The reason is higher the voltage, lesser would be the current, and thereby the power lost during transmission, that is from powerhouse till the distribution center, would be less. But anyway, this has no connection with rectifier, but I will tell you where we will incorporate rectifier. Now, from distribution centers, 11 kV step down to 220 volt and it is given to house. But just think about a mobile charger. In a mobile charger, the input to our battery is DC current, but actually the current in the plug, it is AC current. So how this AC current is converted as DC current? Now, the battery charging unit might be operating at 5 volt. So we have 220 volt available in the power plug. Now this 220 volt have to be first stepped down to 5 volt AC. Then the 5 volt AC have to be converted into a DC. Now you may ask, why the stepping down have to happen initially? Why can't we convert this into DC first, DC of 220 volt first, then why can't we step it down to 5 volt? This is not possible, because how does the transformer work? We have a primary coil and we have a secondary coil. Now transformer will work only with AC current. Now if we are giving a AC of 220 volt here, that can be stepped down to 5 volt or whatever may be the value. We know that ES by EP is equal to NS by NP. So according to this ratio we can step down. But with DC current, transformer will not work, because transformer works on the principle of mutual induction, and mutual induction happen only whenever the current passing through the coil changes. Now when we are giving an AC input, then the current passing through the coil changes at every moment, because see, AC current means the magnitude of current changes continuously and periodically. Okay, so this current changes and this create magnetic flux, and this magnetic flux when linked with a secondary coil, that changes and that creates a mutual induced EMF, and that is given as output. But if it is DC, then the current doesn't change with this, then the magnetic field created with this doesn't change, and that linked magnetic flux with secondary coil, that doesn't change, and there is no mutual induction. So in short, I can say that with only AC we can step down and we can step up, or we can use transformer. With DC current, transformer has no application. We can't step up or step down a DC current. Okay. Now my idea is to deliver the concept that first it have to be stepped down before it is being converted as DC. So we have an input. So first we will connect, we have a transformer, this is the input, then comes, this is primary coil and this is the secondary coil. This is a transformer. Okay. Now from primary to secondary, this is step down. Now this step down, so we have given 220 volt. Let's say this is 5 volt now, step down. But here it is AC and here also it is AC. Now this AC I have to convert as DC. So what I will do, I will connect a diode. And here I will connect my battery or the application which need a DC current. So what will happen? Now this is the input. Okay. So in the first, here I am giving an AC current in primary, and out in the secondary it would be the same AC current, but it would be a step down value. But so this thing you don't need to consider. I have just told why we are using a transformer here. So anyway, this is our input. So this input means for the first half this would be positive, this would be negative. For the half cycle, this is the half cycle. In the next half cycle, this would be negative, this would be positive. Now this is the first half, right? Now when this is positive and this is negative, this is in forward bias. See, positive is connected to P terminal or P type semiconductor and negative is connected to N type semiconductor. So what will happen? The current will move in this direction. So in output, in the load, we will have output for the first half. Now in the second half, this is negative and this one is positive. Negative is connected to P type and positive is connected to N type. Will there be current? No, because only forward bias will allow current to pass, but reverse bias will block current, will not allow current to pass. So in reverse bias there is no current in the output. In the next cycle, what is the next cycle? Positive and negative. So in the next cycle this is positive and this one is negative. So what will happen? This is forward bias, positive to P, negative to N, forward biased. And the next half cycle blocked, then next allows, next blocked. But here there is one problem. This is called as half wave rectifier, and I will tell you what is the problem. I have given an input of this, and this is the output of this current. I am only able to get this half and this half at the output. This is simply wasted. This one is wasted and this one is wasted. I have no use with that on using half wave rectifier. So when I am giving 100 watt in the input to the PN junction diode, I am only able to get 250 watt. I have just wasted half of the power. So this is called as half wave rectifier. Half wave rectifier. Thing is, we got DC current. DC current means these are not constant current but one directional current. Current is only going in one direction. So whenever the current is going, that is going in this direction, this direction. Current will never going in this direction. Direct current in one direction. But the problem here is, see, we are only able to get half wave in the output. Now I will explain you what is full wave rectifier. So this concept is very important. With half wave rectifier we are able to get DC current. The output is varying output, but it is in one direction, and the thing is half of the power is wasted. Now I will explain you what is a full wave rectifier. So half wave rectifier is done. Now full wave rectifier, I have an input 220 watt that have to be stepped down to the desired value. Then I will use a diode here, and I will also connect one more diode here, and these two are now connected to the load here, and this is now connected to the transformer. This is called a sender tapped transformer because this load, one end of the load is connected to the sender of this coil. So this is called as sender tapped rectifier or full wave rectifier. Both are the same. So this is sender tapped. Sender tapped means at half of this, this connection is made at the half of secondary coil. Okay, and with the working principle that doesn't make any change, but I am just saying this is sender tapped. Now what will happen? The input let's say this is input, positive, negative, one more positive and negative. So we are going to consider two cycles, one cycle, one cycle, first half of the first cycle, second half of the first cycle, first half of the second cycle, second half of the second cycle, and we will see the output. This is the output. So this is positive and this is negative till here. Now positive to, now if this is positive, this would be forward biased because positive is connected to positive of the PN junction. This is P and this is N. This is P and this is N. Now this is forward biased, and what will happen to this diode? Reverse biased, because negative is connected to P. So what will happen? Current will go in this direction. Current cannot go to this because this part is now reverse biased, because negative is connected to positive. So this is in reverse biased. Current cannot move in this, move through this branch. Current will only move in this direction. Okay, positive, and this would go negative. So positive, negative, forward biased current we are able to get in load. Okay, so output is there. In the next half, what will happen? In the next half, this is positive. So this is the first half is done, and next half this is positive, this is negative. Okay, here. Now this would be forward biased and this would be reverse biased. Negative with P and here positive with P. So this is forward bias. So current through this bridge is not allowed. So how does current will move? Current will move in this direction. Okay, because through this bridge current will be sent from here. It will get two options here, but current cannot move in this direction because it is reversed biased. So current will, whatever the current comes here, that will go through this direction. We will get an output. See, we are going to draw the output of this resistor. Okay, so this is this load. This is load. In the next half, this would be forward bias, this would be reverse bias. So current in this direction, again this. In the next half, this would be the scenario. Okay, so this is full wave rectifier. Here we are able to get the full power in the output. But the problem here is, see, these are one directional current, but the current is continuously changing its magnitude. But we got the full power in the output. Now in the next video, I will explain you how to convert these output into a DC current of constant magnitude. Okay, thank you.